Right. So in this next section, we are looking at what's called the surface area of a solid revolution, I believe is the official title. And so what we're doing is we're going to have this curve, some curve, and we're going to rotate it around the x-axis or the y-axis and find the surface area. So in the beginning, this kind of looks like what we were doing with the wash method or the shell method of cylindrical shells. Um, and so you might be on first glance think, why do we need to learn another method for this? And well, actually, this is a little bit different because back then, when we were doing the washer method or the shell method, we were finding the volume of a shape like this, where you have curve, you rotate around an axis, and you find the volume. Now we're going to find the surface area. So that's different. Obviously, surface area and volume are different. Um, so it's not the same. And so let's see how we go about getting a formula for this. Well, what do we have? So if we take a strip of this solid or this shape that we have, let's look at this strip. So this strip, we instead of area like we had with the volumes that we were doing, so we're not filling this in, we are just rotating around and we are just getting this circle here. So it's not a solid shape, it is just a circle. So we have the radius here, and we're actually interested in the circumference of this circle. And then we're going to multiply it by the width of it. So this surface area will be the circumference times the width. Now, how can we think of the width? The width is actually, if we're going to get this exact, we're actually going to break this down into this being the arc length, which is what we talked about in the last video. So formula for circumference is 2 pi times the radius. The radius is going to be y, or we could write f of x. And then the width, which is the arc length, is going to be the square root, which is what we talked about in the last video, square root of 1 plus f prime of x squared. And then, of course, if we're going to take many of these strips and take the width of the strip down to 0 and go across the entire length of the shape, then we're going to integrate from a to b. So from this end, which is a, to this end, which is b. We'll pull this 2 pi out since it's constant, and we'll have f of x times the square root of 1 plus f prime of x squared, all under the square root. Well, the 1 plus f prime squared is under the square root, dx. All right, so let's look at an example. So we have the area, we want to find the area of the surface obtained by rotating y equals square root of 4 minus x squared between -1 and 1 about the x-axis. So let's find the derivative of this. So the derivative of square root 4 minus x squared, we get 1/2 times 4 minus x squared to the -1/2 times the derivative of 4 minus x squared, which would be -2x. Simplify this, we get negative x over square root of 4 minus x squared. So now let's plug in our formula. So we have the arc length is 2 pi times the integral from -1 to 1 times the function square root 4 minus x squared times the arc length, which is the square root of 1 plus derivative squared, so -x over square root 4 minus x squared dx. And so this looks fairly complex right now, but like I said in the last video, we can simplify these as much as you can before you even think about integrating. So we have 2 pi from the integral of -1 to 1, square root 4 minus x squared. Now notice both of these are square roots that are multiplied together, so we will eventually just put all this under one square root. Let's square this term first. So we have x squared over 4 minus x squared. That's under the square root, dx. And then let's just put it all under one square root. -1, big square root. We have 4 minus x squared times 1 plus x squared over 4 minus x squared dx. And so then this simplifies down to, let's distribute this 4 minus x squared, or I guess technically we're foiling. So we have 4 minus x squared plus, now 4 minus x squared times x squared over 4 minus x squared. That's going to simplify down to an x squared. And so then this, of course, becomes the square root of 4, which is just 2. And so this really becomes 2 pi integral from -1 to 1 of 2 dx. And so that's going to turn into 4 pi x, and we're going to evaluate from -1 to 1. And so 4 pi times 1 minus -1, which is going to be 2, and then we get our final answer, 8 pi. Okay, so that's really all there is to it. It's really just, you need to remember this formula that uses the arc length formula as a part of it. And then it's just a matter of plugging it in. We don't really have anything. We're not going to do problems that are, too difficult where we're rotating around some other axis, x equals 5 or something like that, and we have to shift everything. It's really just rotate around the x-axis or rotate around the y-axis. If we're rotating around the y-axis, then we just need these in terms of this function in terms of y instead of x, and that'll actually be given that way. So no big deal. And so if you have any questions, you can let me know.